Hello and welcome again to Geometry Online. We're going to do section 11 for tonight, talking about inscribed angles. This one's a little bit shorter, so let's go ahead and get started. We have two vocabulary words tonight. The first one's going to be inscribed angle. So we're talking about inscribed angles. Inscribed means to be scribed or written or drawn inside. So in this case, we're talking about an angle that's drawn inside of a circle. To be more exact, it's an angle formed by two chords of a circle that intersect on the circle. So the result is that you see right here, point E is the vertex of our angle, and it is on the circle. All inscribed angles have the vertex on the circle. And all inscribed angles have what's called an intercepted arc that goes along with them, which is just simply the part of the circle that's inside that angle. So if we were to extend the sides of this angle, ED go further to make it a ray, and EF go further to make it a ray, this part, this arc DF here, would be the intercepted arc. It's the part of the circle that's inside that inscribed angle. So that these extra parts would not be, that the DF is your intercepted arc for your inscribed angle DEF, or you could just call it angle E. Okay, we do have a theorem that goes along with them. Same little picture. We have this inscribed angle DEF, and we have this intercepted arc. There is a relationship between them. We know already that DF is an arc, and so it should have the same measure as its central angle. Well, there's a relationship between that arc and the inscribed angle as well, and that's that the arc is twice as big as the angle. So if you know that the inscribed angle, angle DEF, is, let's say, 30 degrees, that means arc DF would have to be twice that, so it would have to be 60 degrees. Or you could say it the other way around. If you know that arc DF was 100 degrees, that means angle DEF would be 50 degrees, be half of that. So the inscribed angle and the intercepted arc have that kind of 1 to 2 relationship. The angle is half of the arc. And then we have the inscribed quadrilateral theorem, which is almost exactly the same theorem. It's a little different. It's built on that. What it's doing is it's saying, okay, if I look at this, if I have an inscribed quadrilateral, it means I have this four-sided figure, A, B, C, D, drawn inside my circle. I know that angle B has arc AC that is its intercepted arc. So from A to C, kind of this way around, is its intercepted arc. And angle D has arc AC the other way around as its intercepted arc. So if I add those together, those two arcs, I should get the entire circle, which means if those two arcs add up to the entire circle, or 360 degrees, then those two angles should add up to half of that, or 180 degrees. Or to put it in specific words, if a quadrilateral, this one here, ABCD, is inscribed in a circle, then its opposite angles are supplementary. And I do just want to point out here, when I'm talking about a quadrilateral being inscribed, that means all four of its points are on the circle. So it's a little bit more than just drawn inside of it. The points, the vertices, have to actually be on the circle for this to work. Okay. And it works for angle A and angle C as well, of course. So let's do a couple examples. The first one I'm going to deal with inscribed angles. So I can see here, I've got a couple of angles that I'm given, angle B and angle D. And I know that the inscribed angle has to be half of its intercepted arc. So angle B should be half of AC, and angle D should be half of AC. Wait a second. If B is half of AC, and D is also half of AC, shouldn't they be the same? So I'm just going to go ahead and say that angle B and angle D have to be equal. They have to be congruent angles, because they're both half of arc AC. Okay, so that means B and D are congruent. So 10y minus 28 equals 7y minus 1. And then just plug in the measures. B was 10y minus 28. D was 7y minus 1. Then do some algebra. I'm going to add 28 to both sides. So I get 10y equals 7y plus 27. I'm going to subtract my 7y from both sides to get 3y equals 27, and then divide both sides by 3. Get y is 9. Plug that back in for either of the angles. So angle B, 10 times 9 is 90, minus 28 gives me 62. So angle B is 62 degrees. Angle D is also 62 degrees, which means arc AC should be twice that. So if B is 62, AC should be 124, which is just twice of 62. 2 times 62 is 124. Okay. Moving on, inscribed quadrilateral example. I'm going to use that inscribed quadrilateral theorem. I have here a quadrilateral. Looks like kind of kite-shaped looking. It's not necessarily a kite, though. Just kind of looks like it a little. I do know that angle K and angle M both have X expressions on them, and they're opposite, so they should add up to 180. So angle K plus the angle M should give me 180 degrees. So I got it right there. M plus K equals 180. I'm going to plug in my measurements for those. I got M is 4x minus 13. K is 33 plus 6x. Adds up, I should get 180. So combine some like terms. 4x and 6x gives me 10x. Minus 13 plus 33 gives me plus 20. And that still equals 180. Subtract 20 from both sides. Divide both sides by 10. I get x is 16. Okay, so now I can take that 16, I can plug it back into those angles, or I can plug it into angle L. In this case, I went ahead and plugged it into angle L. I know that L was 9x over 2. 9x divided by 2, so 9 times 16 divided by 2. 9 times 16 is 144, divided by 2 is 72. So I end up with angle L is 72 degrees. I could plug it in for any of the other ones. I could even go so far as to find angle J, because if L is 72, J has to be the rest of the 180, so it's got to be 108. 180 minus 72 is 108. So that's your examples for tonight. Some notes. Just one quick reminder, tomorrow we do have a quiz. It is going to be over all this wonderful circle stuff, not the stuff from tonight, not this that you just went over with me, but you know, the 11, 1, 2, and 3 will all be on your test on Friday. Not test, sorry, the quiz that's tomorrow. So make sure you study for it, and I will see you guys in class tomorrow.